So if you really want to contribute meaningfully in this world of data science and artificial intelligence, then you should always be in a position to answer the following three questions. Number one, why did you choose the model that you chose? Number two, what are the advantages and what are the limitations of the model that you have actually chosen? And finally, how confident are you in the solutions that you have obtained? Now, what you don't want to do is be in a position where you take a lot of data, you sort of almost blindfoldedly sort of apply it to a range of machine learning models, which are probably implemented in some tool or the other, and then frankly, after that, hope for the best. So that's something that you should definitely avoid. That's not a great strategy. So if you want to answer questions about the why, the what, and the how, as we posed earlier, then it would be really important to actually have a sort of good foundation in mathematics. And the reason is very simple, because a lot of the models in data science and machine learning actually have a very strong mathematical basis to them. So if our worldview is mathematical foundations plus machine learning models plus code plus data, then the solution that we eventually get is something that we will be much more confident in. A word that we hear very often is models. And here's a quote which I sort of particularly like, and I often remind myself of it as I go through the process of modeling myself. And the quote is as follows: all models are wrong, except that some of them are useful. The context of this quote, or rather my interpretation of the context of this quote, is as follows. The world is a complex place. The real world is complex. And the objective of models is often to identify or to capture some element of reality. So we should really focus on making sure that we can use a model in a useful way, perhaps even in one scenario, and not be so worried about the fact that a particular model may not capture all elements of the real world. As you begin to sort of build your expertise in the mathematical foundations in order to contribute meaningfully in data science and machine learning, what are the initial set of topics that you should be very familiar with? And these would be calculus, linear algebra, analytical geometry, probability and statistics, and optimization. Right? Now, bear in mind that these sort of topics are not exhaustive, but this is the sort of initial skill set that you really need to have so that you can really appreciate the sort of data science and machine learning models which are actually very widely used in practice. So this would be a great place. These topics would be a great place to start and build your expertise across these topics. And of course, then after that, you can sort of build on these topics and get more sophisticated. But this is an initial good set to sort of work with, where you can say that you're fairly confident in understanding how a lot of these models are developed and how these models are actually used in practice. And as you start getting more comfortable with these topics, you will certainly get more comfortable with sort of looking at the why, what, how type questions that we asked earlier, in terms of which model do you choose, what are the advantages and limitations of the model, and how confident you are in your solution, right? So as you gain further expertise in these sort of mathematical areas, the more confident you will get in these sort of why, what, how questions that we've actually posed. We've been making a case for math foundations plus machine learning models plus code plus data as a way of having more confidence in your solution. But we'd like to add one more ingredient to the mix, and that is the process of modeling. So it would be math foundations plus models plus the process of modeling plus code plus data. And it's not just a question about having these different sort of skill sets or different sort of tool sets, but the ingredient which we are saying is also very important, i.e. the process of modeling, is what glues all of this together. And the process of modeling is a sort of an interesting process, and we actually have another video on it. So if you're inclined to see it, please do so.